has been one of those things that I've found really quite fascinating. In the early years, I just couldn't get my head around it. It was all a black art. Couldn't get anybody to tell you anything about it. So everything I've learned about it pretty much has been from the ground up. We've had a few chats with different people over the last day or two saying, you know, I want to do this and I want to do that. Maybe this morning I might be able to throw up a little bit of light on some of this stuff. I'm always available and only too happy to answer any questions. I'm going to pose a few questions to you guys this morning because I think one of the things that you need to think about is that where we're at in the world as it is today with the DCVs is not much different to where we were in the 1950s or in other places with respect to the Navigation Act. There is a requirement to have a properly adjusted compass to safely navigate your vessels. Now, that is a mandatory item. Like it or lump it, that's it. I hear all sorts of rubbish about we don't need it, we've got GPS, we can do this, we can do that. So just accept the fact that that's it. We'll come to reasons why, etc., you know, along the way, and I'll explain a few things to you when we get a few minutes down there on the boat. But one of the things I'm going to do at the moment is this is just a little compass card, okay? I just want you to have a look at it. You'll see that it's very delicate. You've got to treat it very carefully that you don't damage it. You bugger it up completely. But I just want you to have a look at it, and you'll see obviously the printed card on the top. You'll see some bits and pieces underneath. This particular one comes out of a silver compass. It actually sits more or less like that on the pivot. She's a bit knackered, which is why it's in pieces. But there is a particular reason I want you to have a look at this, because this morning I've changed the focus slightly from adjusting compasses as to what we should really be looking at as surveyors when we go on board ships to satisfy ourselves that the compass deviation card, which is what the compass adjuster puts out, is in fact reflecting some degree of relevance and accuracy to the situation. All right, so just have a bit of a look at it. I'm going to ask you a couple of questions about that a bit later on. First thing I do is I've got to apologise about how bad things are in the survey field. Somebody brought out to the attention that the arse out of my pants this morning, so obviously we're so poorly paid up, folks, that we can't do much about it. So apparently I ripped it on the car door as I got in this morning. But anyway, that's life, isn't it? If that's the worst you've seen today, you've done well. Okay, couple of things. I've just sort of splattered this across the board because I haven't made up anything formal, because I don't think it's necessary. I think it's just a matter of putting this out to the whole lot of you. Can I just have a quick show of hands? How many Master 1s have we got here? Okay, we've got a couple. How many people have been involved in compass adjusting on vessels previously? Only one.
You mean like watching it?
Being involved in it one way or another. Okay, yeah, okay. And how many have actually participated in it? Okay, so you've been sort of like skippers on the boats and all the rest of this sort of stuff. Okay, and do we have anybody who has been on the big ships, the over 500 tonners? Okay, all right. One of the things that I think is really important for us to make clear at this stage, the golden rule. I'm going to come back to that at the end of what I've got to say this morning, but it's something you really need to be aware of. I'll pose a question to you. Has anybody been on a ship, say, bigger than 10,000 tonne? Okay, there's a few. All right. With the exceptions of the Master 1s who have had command, has anyone spent any time on the bridge of these ships? Okay. Show of hands. Who knows what BRM is? Not many, eh? Bridge Resource Management. Big deal. Really big deal. Issues such as Costa Concordia, got it wrong. Whole lot of them. Every time you see a big collision or an incident, BRM will be somewhere involved unless it's something quite unusual. One of the points that I really want to drive home here is that basically most of the sort of stuff that we guys are going to see as IIMS surveyors, and particularly if you're a DCV equivalent surveyor, will be in the under 500 tonne. BRM is not a major feature, but if you are thinking about going into the bigger ships, you need to be very cognizant of the fact that at some time you will have some form of control over the vessel. If you have not had command, and if you have not got a decent whack of big ship experience, don't be there, because you are completely out of your league, right? I was on the Carnival Spirit recently. I did the Carnival Legend. I don't know, a whole raft of them. The way that these ships are operated under the SOLAS and IMO is completely different and far more intense than what we see in the DCV world. All right? I just wanted to make that point. Now, let's talk about DCVs, because they're the ones that we are likely to see most of and be involved with. As I said, I want to just change it around a little bit this morning, and the questions are, what is it that we as commercial surveyors are looking for and looking at when we go on board to do an inspection for annual renewal or some other related item where the navigation equipment comes into play? We're looking to satisfy ourselves that the ship is, and that can be ship, boat, whatever you want to call it, but that it's of sufficient standard to be able to be safely navigated. Remember, there is one sole purpose for our being, one, and it's a big word, it starts with an S, safety. That's all we're here for, really. Right? If it's being done safely, then it's probably being done right. Not necessarily, but probably. All right? Okay, so my question here is, what should we be looking for when surveying a DCV commercially? I've used DCV, but it doesn't really matter. You can apply it to a pleasure boat. You can apply it to, your grandpa's putt. It doesn't matter. It's all the same. What are we looking for?
Compliance. Compliance.
Sorry?
Compliance.
Compliance with what?
Regulations and standards that the vessel needs to be equipped to.
Which ones?
Well, it depends on how old the boat is. Could be USL, could be NSCV.
Doesn't matter. You get out of bed every morning, you wear a pair of lace-up shoes. Do you lace them up the same way every day? Of course you do. Right? The thing is, if we go back and... good question, right? Good question. The requirements as far as compass adjusting, not the legalities of it, but the compass adjusting remain the same. Go back in time. How long we have magnetic compasses? Anyone says less than 1,500 years, they're wrong. Job done. Okay, so the thing is that there's been all sorts of progression in the construction of these things. That little unit that I've just sent around there now, wherever it's got to, is very typical of what we see. Even in some of the bigger ships, we're seeing that same form of constructions where we've got sensitive elements underneath, we've got pivots, we've got crowns, and we've got these other bits and pieces that make it a sensitive unit, right? Purpose of it, point to magnetic north, right? I'll come to the other bits and pieces on that in a minute. But what are we actually looking for? We're looking to make sure that what that compass is telling us is truthful. Is that a fair comment? Right, there's not much point. I mean, Adam will tell you, I have all sorts of arguments with people. What the hell's the point of putting a compass on a boat and saying, well, it's a so-and-so boat, it has to have a compass, but it doesn't have to be adjusted. Well, we might as well put our speakers next door to it, we'll put the boom box and all the rest of it. Well, why bother? Pointless. So when it runs aground in the middle of the night because the blokes can't see, we'll say without a compass. Done. That makes sense. Right. So, where are we going to take this? All right, I think what we need to do is to say, okay, what we're looking for is an instrument, because that's what it is, that is properly and correctly installed, properly and correctly adjusted, and can be relied upon in any circumstance to point in the right direction. Kate will probably be able to confirm what I'm saying now. With respect to positions of magnetic compasses under the old system, it was covered under the Navigation Act, correct? The answer is yes to that, I know that for a fact. Under the Navigation Act of Australia 1912, it's there, right? But at very recent times, on several large ships, I've been called back every year. I said, how come we're doing this every year? Apparently, a lot of the flags have now made it an annual thing because it's fallen under safety. Is that correct?
It's not an unreasonable thing to do.
Oh, it makes perfect sense to me, but
Protecting well-adjusted compass.
it's not so much an adjusted compass as it has to be checked by a qualified person, right? And adjusting and checking usually go hand in hand, but so the question is, you know, what's a qualified or a competent person, and I'll come to that in a minute. But you know, it's an interesting fact. I'm seeing a lot more of that now. Anyway, that's a slide aside. All right, so we're looking at what we're going to do with this. We need to be able to walk on board a surveyor and say, right, Mr. Skipper, can I please see your deviation card? You have a little deviation card and it says straight line, zeros, or the odd, you know, little zig-zag. You look at it and think, okay. When we go out to have a look on the cruiser this morning, I want you to have a bit of a look at that, and I want you to see what you can see that's different on that vessel that sort of doesn't quite make sense to you. If you can't pick it, and I mean, there's 5 things at least, all right? And I'm not saying that the vessel installation is no good. I mean, it's quite typical, but there are 5 things that leapt out to me. I was on board it for less than 60 seconds yesterday. And there's 5 things that leapt out to me, and I said, that. Why? Okay? Now, as competent surveyors, looking at your requirements to basically sign off on a vessel, you need to understand what it is you're looking at. Right? I just keep hammering on this. You need to understand. Right, we'll come along a little bit further. We've now got a deviation card, we've got a compass, it all looks wonderful. So we say, all right, let's have a look and say, when was this last done? Does anybody know what the standard is at the moment? Go.
Well, it was 3, now they've extended to 3, maximum 4 under the NC.
That's quite correct, and there's all sorts of little exemptions in there now, which again, you know, leaves me a little bit cold at times, because I think personally it should have gone the other way. It should have been reduced rather than extended. You will find that, particularly within the fishing fleet, they've got more excuses than you can poke with a stick as to why they shouldn't do it. Invariably, most of them don't understand the real value of having a magnetic compass, which then brings me to the next point. What is the value of the magnetic compass? When everything else fails, guess what? It doesn't care, it just keeps pointing magnetic north. So long as it's properly adjusted, and so long as the people understand what it's doing, you will always have direction. You know as well as I do. You're out in the middle of the desert there, and you've got no compass, you've got no idea what's the best you can do. Well, sun generally comes up in the east, but that could be anywhere from what 100 to about 055, something like that. You know, you've got a 40-degree spread there. Same thing going in the west, so you know that somewhere over there is west and somewhere over there is east, or whatever it is. It doesn't make much difference, but the bottom line is that you've got no real idea, which is what the magnetic compass is all about. So we have a properly adjusted magnetic compass, we have a decent paper chart. So long as we've got an engine or a sail and a sound boat under us, there's a pretty fair chance we will be able to point ourselves in the direction in which we want to go. Right? That is what it's all about. Right? Being able to go in a direction to a destination that, for want of a better word, is a safe haven. Righto. What I've done here is I've just fairly quickly whacked up a whole lot of things. Why? Why is it really necessary? Well, I've just explained to you. You've got to be able to know where you're going. All right? Now, please, anybody wants to stop me, ask a question, do it. Okay? When? Graham's just told us. Used to be 3 years, now it's going to be 4 years. There's all sorts of little bits and pieces and wriggles in between it. Where? Where's the location? One of the things, and this is sort of going to be a bit more about what we're doing this morning. Where is the compass supposed to be located in a vessel? Somebody? It's really simple. It has to.
So you can see where you're going.
Okay, it has to be clearly visible and readable from the normal held position. It has to be equipped with a light, right? Remember that, equipped with a working light. Not much point in having a compass with no light in the middle of the night. Okay. It's always preferable to have it on the centre line of the vessel because A, from a compass adjuster's point of view, it makes your life a lot easier. But in a lot of cases, it just doesn't sort of work that way. You just have to work with what the guys have got. When we go on the Carissa, you'll see it's offset. No big deal. Okay. The question then is, who is supposed to be doing these adjustments and calibrations, whatever you like to call it? There's two parties involved here. One is a compass adjuster or a licensed individual, and the other one that's recently appeared is now called a competent person. Now, the competent person can in fact be the master or somebody who is considered to be competent to take a set of deviation readings, we'll call it that. Now, it would be my experience over a lot of years that there are very few competent persons that are actually working on their own vessels. They tend to just come up with some, mumbo jumbo and say, oh, look, I've checked it all out. Even in the big ships, I find that quite often the deviation cards that are produced are, shall we say, less than satisfactory, don't really reflect reality. Again, it's one of those things. Right, how do we do it? The book. The book. Who's got the book with them? How to do it, 3 easy steps. Come on, someone's got it. Sure. Okay. There's some basic elements of doing a compass adjustment, and those elements revolve around animals called the coefficients, and these coefficients are how you correct certain errors. And I'll whip through those very quickly. Because we're on the water this morning, I've got another 10 minutes just here to try and explain whatever I can to you. So I'll just whip through them quickly. Righto, what we've got here is a compass. Now, you've all seen a compass binnacle. Nice big timber thing, usually about 650, 700 in diameter. It's got a big bold compass in it, usually 10 to 12 inches, depends who makes it. They're all the same. Sits on a steel deck, aluminium deck, timber deck, doesn't make much difference. It's always on what we call a plinth. The plinth has got some bolts in it, 4 bolts usually, with slotted holes so that the whole lot can be twisted and turned. If we look at our little boat here, it's supposed to be a boat. This is my mate Doug. This was designed by him. No, I didn't get it quite right. Close. Anyway, with your compass, it has to be pointed fore and aft parallel with the centre line of the vessel, which invariably is the keel. And just as an aside, I'll make a comment. You have all been on boats, ships. You have all seen that almost invariably you have got fore and aft straight keels. Agreed? Yeah, okay. When these boats that we go on are fitted out, in many, many cases, not all, but many, many cases, you will find that bulkheads, transverses, galleys, fit-outs, almost invariably will be at right angles to the keel. Not in every case, but in many cases. You walk through it and you have a look at it next time you're down on a boat, and you will find that the keel that way, and you've got a bulkhead that way. Give or take 15, 90 degrees. Great for the compass man. Right, really important. So, if we come back to this little fella, it doesn't really matter whether it's in a binnacle, it doesn't matter whether it's just a little small compass bowl. Critical element must be fore and aft, right? Has to be fore and aft, because if not, you end up with a lubber line. Remember, all know what a lubber line is? Yes, no? Right, that's that little line in a little bit in the front that sort of says that's the front of the boat. If that's it, you've got zero error. You kick it away a little bit either way, you immediately build in errors. That error is known as coefficient A, right? I'll just call that offset, right? Easily fixed, and probably 1 in 5 boats that I do will have to have the securing screws released and realigned. Boom, job done, no worries. That gets rid of all the problems. Coefficient B, C, D and E are all to do with influence created by the vessel's fields. But just before I go there, I want to ask the question, what what are the factors of influence that are liable to affect our compass? And you're going to see this morning when you go down on the cruiser.
Navigation equipment, too close to the compass.
Yeah, other navigation equipment. All right, so now here.
Metal objects, just random metal objects.
Okay, metal items. Okay, what else?
Cargo.
Cargo is certainly, look, cargo, I'll put that down in its own little area here, because that's an interesting one. If you get involved in the bigger ships, you sometimes see it, not always. We did a job very recently, it might have been in Brisbane, when they put the vessel alongside the wharf, 35 degrees. Boom. Unbelievable. Go off the wharf, disappear up. Nothing to do with the ship, nothing to do with the cargo, all to do with the influence of the wharf. Wharf, cranes, gantry, whatever, so there's all sorts of things there. If we're talking about our DCVs and our small craft, then particularly if you're dealing with landing barges, and for those who work on the west coast and even up in Gladstone there, you know, we've seen all sorts of mystery boxes coming on board to create all sorts of havoc. Now, it would be my view that a prudent master will know what his compass is doing at any point in time, right? And so if he loads a cargo and something gets thrown off, he should be able to say, all right, this is a temporary situation, I acknowledge that it happens, and it's okay, or it's not okay, as the case may be, to be used, all right? Job done. What else? There's a couple of real enemies, and these are the ones, these are these fellas here.
The vessel's own makeup, field.
All right, speakers, radios, and mobiles, why?
Magnets.
Big ring magnets in them. VHFs, the older style VHFs that GME, Icon made, they were great speakers and they had great hand mics, and they'd throw up 30 degrees no problem. Right? And what had happened is the poor old skipper just put his microphone alongside the compass, no bloody compass was no good. As soon as you take it away, there it is, it's perfect. These are things that you really need to look at. Again, have a look on the cruiser this morning. Somebody said something about the ship steel. I agree. And I've just sort of put this in the fixed bracket, which is the construction side of things. It's how the vessel's being built. We see it in all sorts of different vessels, be they fiberglass, timber, aluminium, steel, it doesn't matter. There's all sorts of different effects that you can have. Take, for example, a Veneto 40 yacht, right? Technically speaking, there's nothing in it as far as metal's concerned except a bloody great engine. And where is it? Directly underneath the pedestal where the helmsman stands. Depending upon how well it's set up and what's been done, you know, quite often we anticipate seeing it between 5 and 10 degrees to tweak it. If we've got electric winches for sail handling, they're killers, because of course when you hit the buttons, the solenoids kick in, the electromagnets come in, and the compass will go bang, and you can see 90, 100 degrees go straight into it. That in itself, you know, inconvenient, but not the end of the world, providing that the residual effect dumps quickly, right? It's a thing called hysteresis. You may remember. All right, so the other thing, what's the other thing that we've got that we can't do anything about? Well, magnetic anomalies, yeah, but they're certainly fixed. But I just put the word up here, isogonals. They're lines that join places of equal variation. You know, on the chart you've got your compass rose, and it is invariably set up for true north, right? And then off that you'll find a little arrow that's canted either to the port or the starboard of the north, and that will tell you what the local variation is at any particular point in time, right? So it might, I don't know what it is down here, I can have a look at my phone and see, but on the east coast where I operate, it's anywhere between about 10 and 12 degrees. doesn't really matter. It changes very, very slightly, but that's something we can't do anything about. Isogonals are lines of equal variation. They're sort of like lines of latitude on a normal chart, and they're quite useful to compass adjusters and for people doing long voyages who are transiting through a whole lot of different areas where this variation, the global variation, changes. Again, nothing you can do about it. You just have to be very aware that it exists, because it is one of these things that influences the compass. Having said that, let me go back and ask you a question. If we've got no deviation at all, right, there's no influence from any other force, what are we going to be looking at when we go out on the cruiser this morning in a few minutes' time? When we look at the compass, what sort of course or what sort of heading are we going to be looking at? Right, it's magnetic heading. What's that? Boom, boom. Thank you very much. Okay. No other influence apart from the Earth's magnetic field. We've got to be looking at a magnetic heading. Now, if we, as part of the job of the compass adjuster, is to minimise, preferably remove, any and all deviation. Sometimes it's achievable, sometimes it's not. So you end up with an extra little fella, which I'm just going to put here, right? That little squiggle is called deviation. Perhaps not exactly the right place to put it, but it doesn't matter. All right, so what you need to be aware of is simply that if we start off with a true course, right, let's just say I want to go from here to there, and for me that's 030, right? So I'm going over there, that's 030 degrees true. Now, one thing I can't change, the variation down here. What are we going to call it? 10 degrees what? East? That'll do. Right. We've done a really good job, and there's no deviation. So what sort of heading are we going to steer on our magnetic compass? Remember, we've got no gyros, we've got no GPSs, we've got nothing. We have to make an adjustment to allow for that, right? Why? And the little, what's the word, the rhyme, what they call it? Exactly right. Exactly right. So that becomes 020, and that'll be on the magnetic. So if you're steering 020 magnetic, you're actually steering 0302. Does that make sense? Right. Okay. So poor old boy, means I haven't done my job right. Let's just say that the compass adjuster comes along and he puts in all these magic little bits and pieces, adjusts the compass, and the best he can get it down to is 5 degrees west. So we've got 10 degrees east, 5 degrees west. What sort of course are we going to actually end up steering?
025.
025. All right. Why?
You're a west, not just west.
That'll do very nicely. Thank you very much indeed. Okay. So it's a very simple thing. One of the other things that which is important for us to realise and to understand and be very clear in our head is that if you read the rules for commercial vessels, it says, "Thou shalt not issue a deviation card which has a numeric value of greater than 5 degrees." Which I think is a wonderful thing. There's been a war about that for years, because quite often you go on board and you see 15 degrees and 20 degrees and you think, "Poor old bloke, how's he going to work all this out?" Everybody had a look at that little compass card?
Yes.
How accurate do you reckon you can make a deviation card using that? How closely can you read that? If I said to you steer north, 000, how close to 000 do you reckon you could steer using that card? Now that's off a 6-inch, remember, it's less than 6 inches in diameter, but it's a 6-inch apparent card. So it's a decent slab of card. How good do you reckon you can get? Any other options? I'll tell you, think about it. And this again is one of the issues I've got with the smaller craft. You see little tiddly compasses this big. The lubber line is as thick as the 5-degree interval. Right? On those, they're 5-degree intervals. Agreed? Right. How thick is the lubber line? 1.5, 2 degrees. Best you can steer on a good day, 2 degrees either side of your head, at best, right? Which is why I believe that finally common sense prevailed when they said not more than 5 degrees. So technically speaking, if you've got a maximum of 5 degrees deviation, then you should be able to steer within plus or minus 7, right? 2 degrees either side. Very important, because a lot of people just have got no understanding as to how well they can steer. I can steer within a degree. When you go on board and you look at the deviation cards, and you've all seen the deviation cards, and you see 0.5, 1.3, it's rubbish, absolute rubbish. I see it all the time, particularly in the big ships. 1.25, capable seating as well. You look at it and you think, yep, I've done that on the little computer. I haven't bothered to look at the compass, I've just done it on the computer and I've done it mathematically. Yeah, it doesn't work. Chinese didn't have computers, even though they had abacuses, and they still didn't do it this way. And they're smart, they're really smart, right? So you need to appreciate what it is that you're looking at when you see a deviation card. Really important. You see all these fancy numbers, ask questions. Again, we'll have to be quick this morning, because I want to spend a little bit of time with each and every one of you having a look at this installation, because it's really important that you understand what it is that you're looking at. And this is what I'm seeing a lot of these days, is that people say, yeah, I understand, then you ask them a question, they've got a clue. Okay, we've done the factors of influence. Speakers. Now, the other thing that you need to be aware of that we see in wheelhouses a lot is the pyrotechnics. Flares, yes? Okay. Magnesium, all sorts of bits and pieces. Some prudent skippers think, I'll put it in under the steering wheel or somewhere close by. Always be very careful. We had some a number of instances a couple of years ago where we'd done some compass adjusting on an offshore racing yacht, and they called us back and they just said, it's hopeless, it's no good at all. You know, we're way out, 10 degrees. Nah, that doesn't work, that's not true. So we went down and had a look around, and sure enough, white hand flares, one behind each compass, so bulkhead compasses. Boom. One compass was going this one, one's going that one. You sort of say, well, we won't do that again, will we? So, problem solved. There are any number of strange things that we see that are affecting compasses today. You need to be cognizant of it. So when you look at the deviation card, you look at the installation, you say, does this all look good, does this all feel good? If it doesn't look good and it doesn't feel good, it probably isn't good. Right. I'll just very quickly run through these. Here's our little binnacle, and it doesn't really matter whether we're talking about the nice big binnacle here or the little compass sitting on the dash or set into a binnacle on a helm. All the same. That's the offset. Coefficient B is deviations corrected on a east and west heading. Coefficient C is deviations created on a north and south heading. Coefficient D, which is they're falling up, so they're B. These guys here is C. These guys here are D, and then somewhere down here we've got Flinders Bar. Right? Okay, we'll have a quick look at those this morning. All of these operate by themselves. So if you make a correction for a deviation on east and west, technically speaking, it will have no effect on north and south, and conversely all the way through. Once we get down to D, they're the quadrantal correctors. You've seen the quadrantal correctors, otherwise known as Nelson's balls, or in the Japanese system, they're boxes with flat plates on the side of the binnacle. The Germans came up with some really interesting stuff a few years ago called mu metal strips. And where you had a little domed compass like that, they actually had strips that actually attached to the side there. They were great, they were really good, they were very expensive. All the same, they do the same thing. They're correcting for quadrantal error. So when we actually go out, and I'll show you this morning, we look at the deviations on north, south, east and west. That they're dealt with these guys. We then look at on the quadrantals, north, south, north, east, south, east, north, west, south, west. They all then get bundled all in together, and then at the end of it, we should end up with, hopefully, a fairly straight line. It could be all over the place, it doesn't matter. We'll soon find out. One of the things that you do need to be aware of is that in a lot of the compasses in small boats today, we're seeing adjuster boxes, or we're seeing what they call scissor magnets. And this here represents a little black box like that with a couple of little magnets inside it. There's a little screw arrangement here which can be adjusted to provide magnetic influence, because inside here, tiny magnets, and I mean tiny, you know, they're probably less than 3/16 long and probably less than 3 or 2 millimetres in physical diameter, and they're very powerful, right? So you've got to be really careful. Again, the scissor magnet's something a little bit different. You actually have magnets that are fitted in here like that, the old red and blue tricks, and by winding this in and out, you change the actual forces involved that create some sort of an influence on the compass as far as the positioning of the card is concerned. Okay, it's a little bit hard to cover everything all in one hit, but I'll do whatever I can here so that you know what we're doing when we go out there. Righto, let's move on very quickly now. I'll do the magic numbers. There's magic numbers. 1.2 metres is, in my view, going to solve almost all problems created by magnetic fields. It would be my experience that if you have got a binnacle sitting right there and there is no consequential metal or unusually large forces, then it will probably be pretty close to being reasonably correct. That's not saying that it's perfect. It could have 10 or 15 degrees in it, but you can do something with it. As you reduce this number, the force involved, it magnifies, I think it's the square root or the cube root of the distance. So as the forces, as the distance from the forces reduce, the force itself increases exponentially, so it becomes a very, very strong force at a very short distance. You don't have to move the compass bowl away from that force very far before it starts collapsing very quickly. So 1.2 metres is a wonderful number. Remember that when we go out and have a look at this thing this morning, all right? 1.5 sideways is lovely, very rare that you can get it. Minimums, well, they're sort of self-determining because you need to actually get out there and have a look and see what the compass is doing on the day. Some vessels react well, some vessels just don't react at all. There are any number of occasions where we've actually had to say to the owners of the vessel, sorry fellas, you've got to shoot the compass. They don't like it, but if it doesn't work, there's no point in having it. They're the bits and pieces of the compass. You probably know all about these. You've all seen them in different formats, yes? No? Binnacle, that's the bit that sits on the top of the compass bowl. Quadrantal correctors, rod correctors. Rod correctors is a big compasses, big as your finger, 8 inches long. Seen them? Painted red and blue. They go in this way or they go in that way. Right. Vertical magnets. Vertical magnets, I haven't spoken about that. One of the main things that we see in yachts, particularly in vessels that roll a lot, is the card itself, when it's in operation, will do this. And it becomes very difficult to read it because it's not stable. Has anyone experienced that? Yes, no? Okay, almost invariably, that will be caused by vertical force. And the vertical force is really important to us, particularly in the bigger ships, because of course, you know, they happily roll along, and in a lot of cases, their autopilots are coupled up to a thing called a TMC, transmitting magnetic compass sensor, which sits underneath the bowl. And in some of our smaller craft, we're seeing that as well. So if the compass card is going like this because of the vertical force, well then of course the autopilot's working its little backside off trying to, you know, get the whole thing and keep it on a nice straight track. And as you're probably aware, and just digressing slightly, if you've got a track and you want to go like that, you're fully aware that if you're on an autopilot, it's doing this. Right? It's just kicking backwards and forwards all the way because it's just working on a sensory element. What happens is that with some of these vertical forces, you end up with this sort of stuff that goes all over the paddock. So the poor old autopilot ends up, in a bad case, burning out because it's forever trying to rectify this. Vertical force dealt with by a thing called a VFI, vertical force instrument. All it is a simple balanced needle that sits on a fulcrum, and it's set up ashore to be level. You take it on board the vessel, and then providing the area is clean as far as magnetic fields are concerned. It doesn't matter if there are fields there, so long as you haven't got a whole lot of moving fields, such as induced by electrical cables and conduits and all the rest of it. It will give a fairly good reaction, and it'll either dip one way or another. Now what that is, this sensitive element or sensitive needle is just simply a steel needle, if you like, that is reacting to the magnetic fields, the vertical fields. You can't measure it any other way, either by the you can measure it by heeling the vessel over 15 or 20 degrees, which is mission impossible in the world we live in, or you do it using its VFI. You use the VFI, it takes a measurement, it dips, you then come in and then you put in a vertical magnet in the opposite sense, which pushes the needle back up. It's really simple, it's really straightforward, it's not difficult, you just have to understand what it is that you're doing. Once you've balanced that needle, that card that was doing that will go to that, and it'll be very, very minor. Right, okay, so I'm going to leave it there just at the moment. The enemy, as I've called it here, is you're going to see lots of the enemy out there this morning. Right, now, before we go rocking and rolling out there, has anybody got any questions you want to throw at me now? Because remember, we've got lots of people, we haven't got a lot of time. Yeah, go. Sorry.
Peter, there was a vessel I was on, compass deviation card was due, the compass just came on board, and he struggled, and he had all of it wouldn't stay fixed and adjusted. It was always swinging out. And he said, in the end, it was the vessel was built in the north-south or east-west direction, something like that.
How old was the vessel?
12 years old.
No, game over. What he was talking about is a thing called natal heading. When they build the ship, it doesn't matter where it is, it will take up the Earth's, wherever it is, that variation, right? The Earth's magnetic field will take an influence. Even if you've got a ship that's taken 5 years to build, within 12 months, that natal magnetic field will collapse. And if he's struggling with it, then there's something else that is influencing it. Right? And again, when we go out there this morning, you'll see that there's a whole lot of different things there. But it's an interesting point, that one.
You ended up in some electronic equipment to counter
the problem well, most electronics, look, 5 years ago it was a whole different ballgame. Today the electronics, you can go out there and look at all the Russell stuff out there. Tell me just exactly how much metal is left in it. There's nothing, it's all plastic, it's all PCBs. All the wiring is all either twin, triple or multi-core, which is all insulated. So of course you've got one field going this way, you've got the other field going this way, so they come out to zero. It's more than likely that there is some other influence. For example, the dash was looking a bit sick, so we welded a nice big steel bar underneath it, and then we housed it all in. There's always another reason. I've seen that sort of thing before, and it can be very frustrating. And what you have to do as a compass adjuster is to go right back to basics, work out what the deviations are, and then and it doesn't matter if they can be 180 degrees. It doesn't matter, because you've got to have a starting point. You just got to go out and work it. Righto, off and on.